So hello everyone. Today I will present the HTML and CSS class for this part. So let's look our main element, the app container. So app container is served as our master block. They are centering the application on screen with a width of the 900 pixel. While enforcing a clean top to bottom vertical flexbox flow. So directly below it, the button wrapper. Button wrapper, yeah, as the layout safety mode is fixed the 70 pixel head to ensure the layout does not jump around the app when bar are dynamically added. So inside the master button handle the aesthetic blending, applying the blue background, and then the rounded corner, drop shadow, and smooth hover transitions. So next we look our three column system. There's three. So the download board, they are as the horizontal manager. They are organizing our sections side by side on desktop by allowing them to wrap and stack vertically on the mobile screen. So each column use the panel section class, which is keep the UI clutter by hiding empty column by default. So the moment file enter the queue, JavaScript they are inject the has item state modified class to seamlessly reveal the section. So finally, the download panel is divide the wildcard wrapper inside, simply locking the column head to 400 pixel and enabling a vertical scroll bar to keep long list perfectly content. Next, we go to the CSS. So first is the root. So we set up our foundation in the root the selector by defining the custom CSS variable for our color palettes, like our primary blue, success green, and background shaded. So we make the entire style sheet scalable if we ever want to build dark mode. So we only have to change the color in one place. So we moving to the overall layout. The flexbox is the star of the shadow. So the body and the app container they are pressed together perfectly center. The content is need the top-down flow. Next is the dot button wrapper. They are specifically noticed that it's as a fixed head of the 70 pixel. And this is the crucial UX trick. It's not the main button position in place, ensuring that when the dynamic they are download the queue, so eventually they are appear the beneath it, the button does not generally the shift around the screen. Next we look the master button. So it's designed to be the focal point. They are both rounded with soft drop shadow, but the real magic is in the interactive state to make the UI feel like tactile. And we added the hover and active pseudo classes using the transform transit Y, shifting the button just one pixel up on hover, and down on click give the user immediately specifying feedback. So we go to below the button is our download board. So we are using the flexboard, we flex web. So our three column panel will gradually set on the smaller screen. These panel are completely hidden by the default and only reveal themselves when JavaScript adds the S item class. So and then finally, let's look the individual download raw. So what? So when the new download they are dropped in, it trigger the custom keyframe. That's the keyframe. So the animation they are called in the slide in, making the smoothie appear from the top. So state toggle and conclusion, we manage the actual download progress entirely through the CSS class toggles. Waiting item show dash circle. So when it start, loader icon take over using the infinity spinning, the keyframe. As finish the JavaScript, they apply the complete classes, the simply change the row background to the light green and hide the spinner and reveal our success icon. So this is the success icon. So that's all. Thank you.
Hello everyone, my name is Noor Akamaimani and I'll be talking about the script.js file. So first things first, the back end handles the multi-threaded logic. The front end JavaScript code serves as a semaphore visualizer. So it shows exactly how processes wait for a resource, enter restricted area, and signals other threads when they are done. Okay, first things first, when you see the trigger btn, it shows that it's like a download manager. So the first thing you see here is the alert: it cannot queue new downloads, the server is currently offline. This triggers when the server is offline, so you cannot download anything. It's more of a failsafe. Next thing is to explain the rest. The way the code works is that when the user clicks the download file, a new row is added to the waiting panel. In OS terms, this is similar to the semaphore SEM underscore wait operation. So if all the download slots are currently full, the semaphore value is 0. That means the process is blocked and must sit quietly and wait until the semaphore waiting queue, in the semaphore waiting queue until the spot opens. So um, there's also the function here which I will be showing, which is called move to download. So in the move to download function, it will, once a slot opens up inside the semaphore, uh, the downloading process will be moved to the downloading section until it finishes. So so the best way to say it is, when a download slot becomes available, the backend grants a permit and sends the message to the front end, triggering the move to downloading function. When the file moves from waiting to downloading, this visually shows a process successfully entering the critical section. This panel represents our bounded system limit, ensuring only a safe set number of downloads run at the exact same time. And moving on, the next part is the complete panel. So in the code, as you can see, this is the attempt to start download function. This is the pull download status, and the next part is the finish downloading function. So for the finish downloading section, it changes the status of the download from downloading to complete. So once the download is complete, it moves the file to the completed section. So in semaphore theory, this is sem underscore post, or as we call it, signal operation. It leaves the critical section and the process increases the semaphore slot by 1. And last but not least, so what happens if the network disconnects or the server crashes? There is the handle server crash function that will run immediately, and that function is to show as a exception handling section, and will display messages accordingly, and it'll provide an error, like let's say for this one, connection losses, download server appears to be offline. And that is all for the script.js. I'll pass it over to my fellow crewmates.
Today, we are looking at a Go-based backend server designed to handle long-running background tasks, specifically download job efficiently. In a conventional setup, each background job typically holds an HTTP connection open until it completes. If a single client initiates multiple downloads, it quickly exhausts the browser's connections pool and strains server resources. To resolve these implementations utilize server send events, or SSE. This allows each client to maintain exactly one persistent connection to receive real-time status updates for all their concurrent jobs, significantly optimizing resource utilization. Let us look at the core structures. First, we have the event shroud, which encapsulates the payload sent to the client, consisting of a unique job ID and its current status, such as queue or processing. Architecture itself is managed by the server shroud, which contains three critical components. The first is wait semaphore, which acts as our concurrency rate limiter, ensuring that the server only processes a strictly defined number of concurrent jobs at any given time. The second component is a sync mutex named client mode, which guarantees thread safety, as multiple background workers will be accessing and modifying the client registry simultaneously. Finally, the server maintains a client map that associates a unique client ID with a dedicated Go channel serving as the data pipeline, pushing events directly to the client's browser connection. Let us examine the execution logic, starting with the send method. To prevent a slow or disconnected client from blocking our background workers, this method employs a non-blocking select statement with a default case. If a client's event buffer is full or if they uh, have disconnected, the event is safely dropped rather than stalling the execution track. The core workload is handled by the download function or method. On the invocation, it immediately dispatches a queue status. It then attempts to acquire a slot from the semaphore with a 30-second timeout. If the timeout expires, it updates the status to timeout and exit. Otherwise, upon successfully acquiring a slot, it updates the status to processing, simulates the processing time, and ensure that the semaphore slot is reliably released via a deferral statement once the job reach a complete state. The external interaction is managed by the two distinct HTTP handlers. The first is the download handler. When a client triggers a download request, the server spins up on independent routine to handle the job asynchronously in the background. It then immediately responds with an HTTP 202 accepted status and terminates the initial request response cycle, ensuring that network sockets are not left idling. The real-time updates are driven by the event handler. This is the single long-link connections established with the client. It updates the standard HTTP connection to a persistence stream by configuring the headers of text its event stream. It then instantiates a buffer channel for the client and registers it within our internal map. Once the stream is established, the handler enters a continuous event loop. It awaits incoming events from the client channel, uh, marshals the data with the into JSON and writes it to the response stream using the standard SSA format. The flush methods is explicitly called to ensure immediate data delivery down the line. Crucially, if the client disconnects, the request context is cancelled, terminating the loop. A default function then automatically cleans up the registry by removing the client ID, prevent memory leak. In summary, the main function initiates this server with a maximum concurrency limit of 5 jobs, and now both endpoints. This architecture provides a highly scalable, robust, and thread-safe solution for multiplexing asynchronous jobs tracking over a single connection. Thank you.
Now for my part, I'm going to demo how the actual program works. As you can see, there's a download file on the web page, and currently I have 3 tabs open here. So as I click on this, files will be loaded into the queue. And this is for the second user. And the second user has to wait for the first user to finish first. Let's compare the tabs to a user, for example. And as you can see, only a maximum of 5 files can be in the downloading queue at a time. And once one of the files finish downloading, can signal other files to enter the queue using semaphore. And now the second user download, and I've also implemented the 30-second timeout lah, where if a file waiting in queue has waited for more than 30 seconds, it will be timeout and it will not continue downloading. That's all. Thank you.